Welcome back. I believe you've been able to deal with this y equals to x squared. Okay, let's quickly check it out. This is going to be our example 2. We want to differentiate y equals to x squared from first principle. Okay, we must apply first principle. Now, don't forget what we are driving at. What we want to get is the expression for changing y over changing x, that is delta y over delta x. This is what we want to get from this expression. Okay, so that by the time we are to get dy dx, we are just going to take the limit as delta x tends to 0 of that. Okay, so let's quickly derive delta y over delta x from this question. So to every y, to every change in y, there is a corresponding change in x. So from there we can say that y plus change in y equals to x squared plus 2x delta x plus x plus delta x squared. So we're going to have change in y to be x squared plus 2x delta x plus delta x squared minus y, transferring y to the other side. So we have change in y to be x squared plus 2x delta x plus delta x squared minus, don't forget that y is x squared itself, so we have x squared. So this is out. So then we have change in y to be 2x delta x plus delta x all squared. So dividing both sides, dividing through by change in x. Okay, dividing through by delta x. So what do we have there? Delta y over delta x equals to 2x plus delta x. Okay, so definitely dy dx, which is equal to the limit as delta x tends to 0 of what? 2x plus delta x, because our expression for delta y over delta x is 2x plus delta x from this equation. So finally dy dx is equal to 2x. What about the second one? We have y equals to 1 over x. So what we want to get is the expression for change delta y over delta x. So how do we handle that? So like I said, to every change in y, there's a corresponding change. There's a corresponding change in x. Okay, there's a corresponding change in x. So from here, we're going to have our change in y to be equal to 1 over x plus delta x minus y, right? So don't forget that y is 1 over x. So let's substitute. We have change in y equals to 1 over x plus delta x minus 1 over x. Okay, can we just simplify this fraction? So we have delta y equals to the LCM x into x plus delta x. Then this cancels out. We have x minus x plus delta x. Okay, so we can have delta y to be x minus x plus delta x over x into x plus delta x. So this is out. We have delta y to be equals to delta x over x into x plus delta x. So we are going to divide both sides, dividing both sides by delta x. So what do we have there? Delta y over delta x equals to delta x over x into x plus delta x multiplied by 1 over delta x. Okay, we are dividing both sides by delta x. So these cancel out. Alright. So that means we're going to have change in y over change in x to be 1 over x into x plus delta x. So the limit dy dx equals to the limit as change in x tends to 0 of 1 over x into x plus delta x. Of course, if you substitute delta x as 0 into this function, all you're going to have is 1 over x squared, which can also be expressed as x squared minus 2. So I leave you in the hands of this. Thank you and God bless you.